We're going to start this section by talking about how to set up null and alternative hypotheses for hypothesis testing questions. This is usually going to be the first step in generally any hypothesis testing question, so it's a really important skill that we're going to want to have for our toolbox. So in each one of these questions, we've got 3 of them here. We just want to talk about the null hypothesis and the alternative hypothesis. So let's just jump right in. Number 1 says, a TV talk show host claims that fewer than 15% of college students have full-time jobs. Now, in general, I tend to think it's going to be easier to start with the alternative hypothesis. This is actually what I'm going to start with first, because this should usually show up as a claim that's being made. Usually in these hypothesis testing questions, somebody's going to either ask a question or they're going to make a claim. So in this case, we're actually using that word claim. We're saying fewer than 15% of college students have full-time jobs. So I want to talk about the percentage of college students that have full-time jobs. So I need my null hypothesis, which is H naught, and my alternative hypothesis, which is HA. So when I talk about these, I just said I'm going to start with the alternative hypothesis first. The first thing you need to decide is what is your parameter. The common parameters that we're going to see are P, which is the population proportion, and mu, which is the population mean. You may see others from time to time. There may be variations of proportions and means if I have 2 populations I'm pulling them from, for example, but these are primarily the 2 that we're going to see most often. In chapters 5 and 6, we will primarily be using P as our parameter, and then in chapter 7, we'll be using the mean as our parameter most often, but here we have a few of each just to get some practice. So anytime we're talking about a percentage or a proportion, that means that our parameter is going to be P. So both of these hypotheses, H naught and HA, are going to be statements about the population proportion P. So they're both going to start by talking about P, and they're going to be some relationship to a number which should hopefully be given to us in the problem. So for that alternative hypothesis, I'm going to look at that claim, and this says fewer than 15%. So that's what I'm looking at here. When you look at your alternative hypothesis, in general, when we're talking about especially proportions right here, we really have one of 3 options. We're either doing a left tail test, which means P is less than some number. We've got a right tail test, which says P is greater than some number. Or we could be doing a 2-tailed test, which says P is not equal to some number. It's going to be one of these 3 right here. And the way that we make this determination is based on the question or the claim that's being made in our problem. So in this case, we said fewer than 15%. So I'm looking at that fewer than. Fewer than sure makes me think of less than. So we're talking about less than. In this case, I'm going to look at, well, we're talking about 15%. We're always working with percentages as proportions, so I'm just going to make sure that I write that 15% as a proportion would be 0.15. So my alternative hypothesis is P is less than 0.15. And once you've got your alternative hypothesis, the null hypothesis follows quite simply, really, because you're going to always have the exact same parameter. So we made a statement about proportions down here in the alternative hypothesis. So we've already said that our parameter is going to be proportions for our null hypothesis. The next thing I need to decide is what's going to go right here. What's going to be this relationship? Now, some books might do this a little bit differently. The way that we're going to use this in our class is for the null hypothesis. The null hypothesis is always going to be a statement of equality. So we're always going to say P is equal to some number. And we just have to figure out what that some number is. And luckily for us, it's actually just going to be the same number that we used in our alternative hypothesis. So we're going to say P is equal to 0.15. And what the null hypothesis represents, this kind of represents our current belief. So we have to start this problem by saying, okay, we have to make some assumptions. In this case, we're going to assume that p is equal to 0.15. And then we're going to operate under that assumption and see what's more or less likely based on the calculations that we're going to perform later on in the hypothesis test. So once you have that alternative hypothesis, the null hypothesis is always going to be equal to that same number that we have right there from the alternative hypothesis. Let's take a look at another one here. Number 2 says a light bulb manufacturer claims that its light bulbs have an average life longer than 3,000 hours. So I'm looking at this, my mind is kind of drawn to this word right here, average, which, hey, average, we're probably talking about a population average. So when we go to set up our null hypothesis and our alternative hypothesis, the parameter that we're going to be using is the population mean, which is that Greek letter mu. So I'm once again going to start with my alternative hypothesis here. We've already said we're talking about an average, and I'm just going to look for some sort of claim that's being made. So this says average life longer than 3,000 hours. So longer than makes me think more than, or perhaps greater than whatever value they're talking about here, which in this case is 3,000 hours. So I'm going to say that the population mean is greater than 3,000 hours. Once I have this alternative hypothesis, the null hypothesis we just said is always a statement of equality. So we're going to start by saying the mean is equal to, and then I'm going to use that same number, 3,000 hours. We should always be using the same number in both our null hypothesis and our alternative hypothesis. So we're always going to see the same number appearing in both of those two statements. And then lastly down here, number 3 says the average price of gasoline is reported to be $2.84. So this one I think is a little bit trickier, but I'm going to start it off the same way. We need to talk about the null hypothesis, H0, and the alternative hypothesis, HA. And once again, what's our parameter? In this case, it's average, so we should be talking about our population average mu. And then this one I think is a little bit trickier because there's not really a statement that's being made. And you'll see this pop up every now and then where there's not really like a question or a statement being made here. Here, in this case, we're not saying it's necessarily more than $2.84 or less than $2.84. In these cases, if it's not giving any indication whether it's less than or greater than that value, then we're going to go ahead and say that this is a two-tailed test, which means our alternative hypothesis is that the mean is not equal to $2.84. And you might see some words pop up like, is there a difference, or is this average price different than, or is it not this? Anything that kind of uses that language that doesn't necessarily indicate whether we're talking about specifically more than or less than. And then once we have that, similarly to the other two questions that we've looked at, the null hypothesis then is a statement of equality, is the mean is equal to $2.84.